Hello, my esteemed viewers. In the previous tutorials on machine learning, which formed the foundation concepts, we said even machines can do mistakes or errors in the form of bias, overfitting, underfitting. We also understood as to what a well-posed problem is and how the machine learning algorithms can be adopted to make machines to learn so-called well-posed problems. In this tutorial, the designing of a learning system and the steps involved are clearly explained. As the topic is voluminous and it comes through at least 5 distinct steps, we will move inch by inch in short spanned tutorials. Before making a machine to do some task independently without human intervention, we need to design the learning system. That is the heart of the matter. And designing a learning system involves 5 distinct steps. 1. Choosing the training experience. 2. Choosing the target function. 3. Choosing the representation for target function. 4. Choosing the function approximation algorithm. 5. The final design. Now, the example that we have chosen is to design a machine that can play checkers game. As there are no a priori algorithms for this, as there are no tailor-made algorithms for this, it is a well-posed problem. It has a solution. The problem has a task. The problem has a performance measure, and the problem will be given a lot of experience in the form of board states, different board states. Therefore, the task for this machine learning exercise is to make a machine to learn to play checkers with a goal of becoming a participant in the World Checkers Tournament, and possibly it may emerge out as a winner. The performance measure is the percentage times the machine wins the game, and the experience is the various states of checkerboards in terms of anticipated movements of the pawns by opponent and the befitting movements of the machine and the associated target points or the points that are gained. We will explain the first step of making a machine to learn how to play checkers. The first step, as it was indicated in the previous slide, is choosing the training experience. It's very important to note that the choice of kind of training experience will have a significant role in the final performance or outcome of the machine. However, choosing training experience or the nature of experience that has been chosen has 3 important attributes. Because the kind of training experience will have significant role in the final performance. It has 3 attributes or 3 characteristic features. 1. Whether the training experience provides direct feedback or indirect feedback. The degrees to which the learner can control the sequence of examples forms the second characteristic. And the third characteristic is how well the training examples are distributed in the training set. Choosing the training experience. The first attribute is direct or indirect. We will choose 3 examples to reinforce our understanding of the concepts as to what do we mean by direct feedback or indirect feedback. Consider the offline learning of music. There will be a teacher, and if mistakes are committed, the teacher will correct. And even if we even if we perform the music in front of the teacher, we will be able to correct then and there only. So this is the meaning of direct feedback. As far as online music is concerned, there is a stored program, and we will just watch that, and we will try to learn, and it may be anything, and it's a stored program once again, and there will be some hints coming on the screen, and we will try to adjust, and we will try to manipulate anyway. And if you are taken to a concert, a direct concert, a real concert, I think the results of such a real concert or real performance is always questionable. In the same token, the learning of driving of a car can also have direct inputs or indirect inputs. And if we learn by attending a driving school, there will be a tutor, there will be a trainer who will be sitting beside us, and he will be guiding all the way. And if we do the mistakes, there will be direct input that is available, direct feedback that is available. Or we can store some kind of a audio and video, and we can start driving, and it will simply go on telling, start the car, hold the steering, apply the brakes, like this, in a sequential matter, whether or not we are into that particular situation. And after having learned in a virtual environment with indirect feedbacks, and if you are taken to direct driving in a road with vehicular traffic, the performance may be disastrous. And another example that can be quoted wherein we can gain direct inputs is learning experimentations in laboratories with our physical presence. And there we will commit mistakes, the results are not coming, there is a lot of learning that happens, and we will get direct inputs then and there only. As far as virtual labs are concerned, there will be stored explanations, and the experiments will be conducted. We cannot ask questions, it will not answer our questions, because there is no facility to ask the questions and also answer the questions. We should be simply watching. And if you are asked to conduct an experiment in a real time scenario, I think there will be a lot of flips. So as far as design of a checkers playing machine, the direct experience, we may provide different movement states and correct move for each. There will be different scenarios. There is a teacher sitting beside, or we ourselves can learn by treating another opponent sitting in front of us. And for every movement, here is a movement, and this is the movement that we did before, and we realized this will lead to losing the game, therefore we will revert back and we will learn. There is a direct feedback, and at times we may feel, I think I should not have moved this way. So these are all direct feedbacks that we are going to get. As far as indirect feedbacks are concerned, we will have most of the indirect experience could be moving sequences, different sequences or different board states. And if it is the board state like this, and this is going to happen. And if this is the board state, this is going to happen. If the player is having black checkers, and if this is the kind of the movement, it may eventually go for a loss, because there are 4 pawns as far as this fellow is concerned, and there are only 2 pawns left for the opponent. So this kind of a movement has led to failure in the previous stored example. And here is another situation. This situation has rendered the fellow with the red pawns losing the game. So we should have stored board states and the consequent effects that have emerged in the previous games, like that. And we have to collect lot of board states. More the board states we collect, and the target experience we collect, board states and target experience, the experience that was gained in the previous game. All these things are there, and it becomes uncertain whether if we are put up in a realistic way, whether we win or lose, because these are all the things which have happened in the past. Okay, information about the correctness of specific moves early in the game must be inferred indirectly from the fact that the game was eventually won or lost. Okay. And this kind of movement, let me simplify this further. This kind of movement has led to the loss for this particular person who is playing, maybe our opponent, and this particular movement has given this fellow or an opponent a win. And this kind of movement, Samir here mentioned Samir over here with 3 pawns, one above the other, and 2 pawns left with our opponent, and this particular situation or this particular board state has given a win for the fellow who was holding the black pawns. So here the learner faces an additional problem of credit assignment, or determining the degree to which each move in the sequence deserves a credit or a blame. Blame means losing the game. Credit means getting some points. Let us say this kind of a movement for a white pawn owner is attributed to 0.5. It may be a win or it may be a loss, this particular situation. And this particular situation, as far as red pawns are concerned, or the person with the red pawns are concerned, there are 70% of chances, because the credit given to this is 0.7, and however there is a chance for this person to lose the game by 0.3. So the indirect experience or indirect feedback, as far as checkers game is concerned, will lead to a problem of credit assignment. Credit assignment is to be done for every move, depending on whatever the sequences that we have stored, the experiences that we have gained in the previous games. So it demands lot of experience or lot of board states and the consequent effects. That is the thing. Yeah, this particular kind of movement or this particular board state may correspond to a credit of 0.6. That is 0.6, 60% is to the winner side, therefore 40% may be losing the game, and this is the credit given to this. Second important attribute is the degree to which the learner controls the sequence of training examples. Direct examples. So let us say degree to which means if I let us say we will revert back to the driving experience. When we sit in the driver's seat, 3 possible situations may occur. 1, we will sit, the guide will be sitting beside us and he will be guiding all the way. He will say, please start the machine, please start the engine, put on the engine, hold the steering, start the car, move. That is the instructions. So we will just go along the instructions and we will start the car, we will hold the steering, and we will just start move. Second situations could be we will do on our own only, and we will start and we will move, we will start moving, and whenever the doubts arise, we will ask the teacher, who will be sitting beside us. This is the second kind of control that we can have in a driving experience. And the third kind of control is we will do everything. We do commit mistakes. Depending on the outcome, we correct for ourselves. These are all different kinds of controls. In a music learning class also, we will sit in the music class, we will open the book, and we will start with the initial swaras or whatever, or the tones or the beats, and we will we will wait for the teacher's intervention for our help. And in the second case, we will start rendering the music, and if we commit the mistakes and if we get doubts at certain points in time during our rendition, we will ask the teacher. And the third kind of control is we will start just doing, and we will correct for ourselves, and we will regret for having committed the mistakes, and by mistakes we are going to learn. And this is the third type of control. And in case of laboratory conduction of experiments, we will start, and we will get the instructions, step-by-step instruction by the teacher, and we will perform the experimentation. That is first kind of control. The control will be fully relied on the teacher. And in the second type of control, we will start doing the experimentation. Whenever we get the doubt, we will ask the teacher. In the third kind of control, we will learn for ourselves. It is a self-learning kind of an experience, and this is also an experience. These are all the three possible controls is possible. Okay, and getting the guidance for every step, that is the first control, and doing for ourselves. In the case of doubts, we will ask the teacher. That is the second type of control. The third type of control is on the training examples I'm telling. The third kind of control is we will commit mistakes, we will learn for ourselves. So this is the first kind of examples as far as checkers game is concerned. As far as the second attribute is concerned, rely on the teacher to select informative board states and to provide the correct move for each. Like this. For every step he will be explaining, the teacher will be explaining. And the second kind of experience is we will start doing, and in the case of doubts we will ask the teacher. And in the third kind of control, the learner might himself propose board states. Okay, this is the move, it's going to happen like this. In the previous move I have erred, so this time I should not err. Okay, and if at all there is a confusion that occurs, we may ask the teacher, or we may correct for ourselves. It learns by playing against itself as far as this case is concerned, because there is no direct tutor. Of course, this checkers play game will fall under indirect experience, because the checkers game machine, the machine which has learned the checker games, it has learned by playing itself with no teacher. This last case, the learner may choose between the experimenting and novel board states that is the third kind of control, has not yet considered, or gaining its skill by playing minor variations of lines of play it currently finds most promising. This situation could be provided by a random process. Of course, we can throw open to the machine different random states of board or board states. That is what we mean by telling random process outside the learner's control. Simply throwing a particular situation and making the machine to learn how it should move in order to get good credit point, and it will do that depending on the stored experiences. And if this is the state of the board, this should be the moment. That's what the previous experience will give to the machine. Setting in which the learner may pose various types of queries to an expert teacher. Expert teacher means stored program, stored experience, and the corresponding credit that was obtained in the previous games or in the examples. And settings in which the learner collects training examples by autonomously exploring its environment. Okay, and it is doing like this, and these are all the different states, and each and every state is associated with the credit. See, this could be moved like this or like this. In any direction it could have been moved, and in the previous experience it was moved in this direction, and it ended up in a credit of 0.4 because it was a loss. And as far as this pawn is concerned, if this pawn were to be moved in this direction, that was the credit obtained in the previous game. Like this, different board states and different credits. The third important attribute of the first step, that is examples, the kind of training experience and how well it represents the distribution of examples. And if we take the example of learning music, we may play only a very simple, let us say, simple rendition or simple simple song again and again repeatedly, without going for a complicated raga or complicated shruti or complicated beat, whatever you assume. And it happens in a closed door room, and we will never have chosen complex renditions with different ragas. This is the thing, and only one kind of experience. As far as driving is concerned, the first kind of experience is driving only on the playground every time. It cannot happen, and we have to drive the car in a playground, and we have to take to the road which is full of vehicular traffic. There also we should learn. So that comes to second kind of distribution of our examples. And we should also drive in a hilly area, okay, up the hill, down the hill, and here playing different tunes or ragas, doing all kinds of experiments, driving in a busy road, hilly area or traffic, and doing different kinds of experiments that are not listed in a typical laboratory, open kind of experiments, open questions. This is a distribution of examples from simple experiments, complicated experiments, and experiments which are not done in the past. So this is how the examples can be distributed. As far as checkers play is concerned, its training experience consists of only of games played against itself. There is an obvious danger that this training experience might not be fully representative of the distribution of situations over which it will later be tested. In most current theory of machine learning, it rests on the crucial assumption that the distribution of training examples is identical to the distribution of test examples. And of course, as far as checkers game is concerned, we should have huge database or huge exemplars involving different kinds of board states, and the degree to which it was weighed, and the expectancy of winning the game or losing the game for different board states. And different board states will give us a huge distribution of examples, and no particular situation or no precarious situation is left over, and this example set will have all possible kinds of board states. Okay, if we have this, the learning experience gained by the machine, because after all machine here is playing for itself, along with itself, that is the opponent and that is the contestant. Therefore, you should be provided with lot of experiences in order to make this machine learning exercise with special reference to checkers play or checkers gameplay will become fruitful, and there will be great learning done by the machines. Therefore, it depends upon the training experience that is given. So first step is explained, my esteemed viewers, and in the next tutorial we will come with the explanation of the second step of this learning exercise. Until then, bye, and if you have liked this video, kindly subscribe to my channel. Thank you.